Everyone, welcome to our class. Today, let's continue to talk about the process. So we know the process is the way one abstraction your kernel use it to control. So each of our program is like a process inside the operating systems, and your kernel try to use the process as a basic unit to manage the resource for each of your running program. So which means it also provide a lot of information for your program. For example, what's the ID? There's so many process, right? So definitely you need to give a number. Otherwise, your operating system, your kernel won't know which process is running yet. It's running or is haven't running yet. So in this case, how we get the process ID? So the process ID is really interesting information, and you sometimes might use this information to do some like a strategy to manage your program. So there's one system code. It's called get PID. This is the process ID. So it's return integer. So this is integer, and get PID is simple because it's get ID, and what's ID? The process ID. Okay, so this is how you get your process ID. So this is an example shows how we get the PID. So we use we have a main function, and inside of main function we try to print out its own process ID. And after it's get PID, it's go to while loop, which means it's never stop. It's going to an infinite loop. And let's see what happened for this program. Okay. So if we try to run this program, we can do GCC fork.c-o fork, and we can run a fork. So when we run a fork, we can see the process ID is equal to this number, right? So how we actually check it in our operating systems? Let's try to look at. If you type PS, it will show all process information you have. And you can see you have a program fork, which is running program. It's never stop because it's infinite loop. This running program fork with this process ID, and this is the same information you print out in your program. So this is an example how you get your process ID in your program. Okay, so why we need this process ID? If the running program only inside the process, so which means this running program should not know like other process, right? Based on our understanding. The kernel forbid they communicate to each other. The process should only know it. In this case, why the process need to know the ID? The ID should belong to the kernel. Why your program needs to know? Because in this example, in this lecture, we will talk about actually inside your program, you can try to generate another program. So it's kind of child process. You use your process, generate another one. So the process one, you can generate process two. The process two can generate more. For example, process three. Your process also can generate another process four. Depends on how you use it. So actually, you can generate a different process. You can use your program to generate different process. Actually, your kernel also use this strategy to generate some new program to support your kernel manage these systems. So this is a very important concept for today. And how we do it. The system code is called fork. Fork is very powerful and very useful term to create a new process. And how it's actually do in your program. Let's see this example. Okay, so how forks actually do. So I always want to start to talk about Ninja first because they are so similar. So the Ninja has some like special move. For this move, when Ninja do the clone clone move, it's created another Ninja. So it's created another one. So it's very similar to fork. When your Ninja say fork, it can generate two Ninjas. So very similar to your code. Your code, you have a source code, but when you do a PID equal to fork, when you do a fork, actually it's create another process. So when you do a fork, it's create another process, okay? So it's give you another process with the same content of the original one. It look like it's just look like the same. The code is the same, but they have their own independent virtual memory. So they both these process are independent process. They are not belong to the same process. They are different process, but different process with the same code to run the same code at the same time. So this is the idea how you use fork to create a new process. And this new process we call it a child process. And the original process we call it parent process. So the parent process use a fork to create a child process. This is the idea. Let's take a look of this example. In this example, we print out something like before the fork, we print a message. After we do the fork, we print a message. So because fork will generate another process and generate two process, both process will be run the same code. And because the fork is here, so both process will run the code stop from here. They will not go back to check the before fork. It's all about the after. So you should be able to see there's a two after fork message be print out in your program. So let's look at this example. First one with GCC. You can see there's one message before the fork, but there's two message after the fork, which means before the fork, you only have one process. After the fork, you got two process. So this is the idea, okay? Let's look at what's the process ID for these two example, okay? So we try to add one more while loop. So we want to stop so we can check the PID. So here we can see before the fork, the process ID, let's say the process ID, process ID equal to %I. Yes. Okay. So you can see we have the process ID before the fork, and we print out the process ID after the fork. So what's it look like? Okay. So again, we do GCC, then we execute it, and you can see the first process ID is this number, and the second process after the fork, the second process got this process ID. So you have one process with this process ID. It's generate another process with this process ID. And it's of course, it will print out its original, the parent's process ID. So let's look at the PS. You can see there's a two program has the same name in your systems with different process ID, 33A and 339. Okay, means you create a new process, two new process. This is an example like why you can get this like a weird like a behavior, but actually this is not so weird because you use a process, create a new process and give a new process ID. So this is the reason why you can see two processes inside your systems. Let's take a look of the process ID, this part. So right now, since it's like just like execute the same code again, like in different process. When you create one process, it's like create another process running the same code. It's not so interesting, right? Usually when we create a new process, we want this new process to do something different, not the same. For example, I want to create two processes, one be the player, one be the AI. We want AI to do something different to a player, right? So in this case, how we deal with this? So the idea to deal with this is if we can use if statement to separate this process, it will be very useful. Why if statement can help this? Okay, the idea is that the fork decision code, when you call fork, the fork will return two different value to different process. It will return the child process ID to the parent process. Okay, it will return child process ID to the parent process. It will return 0 to child process So it's actually it's return two different value to different process. If you know how to use it, it's really cool because you can just use PID equal fork, and you can use the PID to do some separate. If PID not equal to 0, means it's a parent process because you got the child process ID. So you can do something like, okay, I have a process ID of my own get PID, then my child process you can do something like that. So in this case, you can show your what's your process ID, what's your child process ID, and of course we can do the same for another one, which is the parent, the child. The child, you can see what's the child process ID by use the get PID. You can also say my parent process ID equal. Okay, so here's the thing, how you get your parent's process ID. So there's another system code called get PPID. So P, first P means parent, second P means process. Get parent's process ID, okay? So if you use get PPID, you can get your parent process ID. This is the idea. Okay, let's try to run it. Again, we do GCC, then we run it. We run a fork. And you can see the process ID equal to, this is for a parent. So the process ID of parent is this number, then child process ID is this number, and it's matched to the child process ID. And the child process ID can show the parent process ID by use get PPID, this system code. This is how you like use this couple system code to get your child, your parent, or your own process ID. Yo, I still confused how to trace this process, how I use fork. I think it's a little bit weird to me why a program can generate another program. If it can generate a program, how can I know which one is child, which one is parent? I am so confused about it. Can you tell me how to identify which is a child process, which is a parent process? Don't worry, we will cover a couple examples in our next video to show how to like identify which is a child process, which is parent process, how many process you created in your program. Okay, so if you are interested to see more example, please check the next video. Okay, so I hope you enjoyed today's video. See you next time. The fork system code is awesome.